Welcome to solverfy.
For this question, they are wanting us to find the partial pressure of the hydroxyl radical as well as the mole percent. To do this, they give us the concentration. So the concentration of the radical, the hydroxyl radical, is equal to 2.5 times 10 to the 12th molecules per meter cubed. They tell us that the pressure for this reaction is equal to 1 atmosphere. They tell us that our temperature is equal to 22 degrees Celsius. I'm going to add 273 Kelvin to this, so the temperature is going to be 295 Kelvin. We are looking for the partial pressure of the hydroxyl radical, and we are also looking for the mole percent. And for this question, I'm going to be using the R value. R is equal to 0.0821 liters atmosphere per mole Kelvin. Alright, so to start out, let's find out how many moles of the radical that we have. So moles of our hydroxyl radical. To do this, we're going to use Avogadro's number. So Avogadro's number, which is equal to 6.023 times 10 to the 23rd molecules per mole. So to find the moles of our radical, we're going to take the concentration, so 2.5 times 10 to the 12th molecules, and we are going to divide this by Avogadro's number, so 6.023 times 10 to the 23rd molecules per mole, so that way we get the number of moles. When we do this, our number of moles is going to be 4.15 times 10 to the negative 12th moles of our radical. We know our volume is equal to 1 meter cubed. 1 meter cubed is essentially equal to 1,000 liters. So now that we're going to find our pressure of our radical, I'm going to be using this as our volume. So the pressure of our radical is going to be equal to the moles times our R value times our temperature divided by the volume. So this is going to be 4.15 times 10 to the negative 12th moles times our R value, so 0.0821 liters atmosphere per mole Kelvin. We're going to times that by our temperature, which is 295 Kelvin. And then we are going to divide all of this by 1,000 liters. So when we calculate the pressure of our radical, or the partial pressure of our radical, it's going to equal 1.01 times 10 to the negative 13 atmospheres. And this is our partial pressure of the hydroxyl radical. To figure out the mole percent, we're going to be needing to use the mole fraction. So mole fraction of our radical in the air. So our mole fraction is going to be equal to our partial pressure of our radical divided by the total pressure. So we know our partial pressure is 1.01 times 10 to the negative 13 atmospheres, and we know that our pressure, total pressure, is equal to 1 atmosphere. So our mole fraction is 1.01 times 10 to the negative 13. So to get our mole fraction into a mole percent, we're just going to take 1.01 times 10 to the negative 13. We're just going to times this by 100 So our mole percent is going to equal 1.0 or 1.01 times 10 to the negative 12%. And that is our mole fraction for this problem.